System of linear equation problems often present in word problems. There are a few classic cases. Let's take a look at one of them that deals with prices and amounts. The school that Lisa goes to is selling tickets to the annual talent show. On the first day of ticket sales, the school sold 4 senior tickets and 5 student tickets for a total of $102. So we typically start with a price and amount of one group or item and a price and amount of another group and item. In this case, we've got 4 senior citizens. So let's call that 4C, the number times the price. We don't know the price. We'll call that C. And 5 student tickets for a total of $102. So that's going to be plus the price and amount of student tickets. Well, there are 5 students, and we'll call the price of a student ticket S. We don't know that, okay? And in total, we know that equals $102. Well, if we keep going, the school took in $126 on the second day by selling 7 senior citizen tickets and 5 student tickets. So we have a second equation here. We can say 7 senior citizens times the price of a senior citizen ticket plus 5 student tickets, again, times the price of student tickets, equals, in this case, $126. Now I have 2 equations in standard form, which often cases means I want to solve by elimination. I can do that because I can see right away if I subtract the second equation from the first, my s's will cancel as variables. So I'll get 4c minus 7c becomes minus 3c. 5s minus 5s is 0. And that equals 102 minus 126, which is minus 24. I'm going to divide through by negative 3. C equals $8. So the price of a senior citizen ticket is $8. What's the price of a student ticket? Well, I'm going to plug that back into the equation. So 4 times C, which is 8, plus 5 times S, our student ticket price, must equal $102. Well, that's 32 plus 5S equals 102. Let's subtract 32 from both sides. 5S equals 102 minus 32 is 70. S equals 70 divided by 5, or $14. So the price of a senior citizen ticket is $8. The price of one student ticket is $14. And that's how we answered these types of problems through a system of linear equations. Distance equals rate times time problems are another classic case of systems of linear equations. Almost always, they present as 2 legs of a journey. You have problems where somebody goes from point A to point B and then returns back to point A. Or you might have 2 parties that are apart, maybe 2 trains, leave from 2 separate cities and meet somewhere in between. You might have 2 separate legs of the same group on the same journey, leg 1 and leg 2. You could have one group leaves first, the other group or party leaves afterward and catches up at some point to the first party. And you could have parties leaving the same point and going in different directions, getting a further and further distance apart. Regardless of these few typical distance equals rate times time scenarios, they always have 2 legs to the journey, which means you have 2 distance equals rate times equations to set up, and possibly a total distance rate times time equation to help you work through the systems of equations. So let's look at this example. As Sally rides her bicycle 5 miles from her house to the beach in 30 minutes and then returns at 5 miles per hour, what is her average speed over the entire trip? Okay, this is the first scenario where Sally's riding to one point and then returning over the same distance. That's one of the key assumptions here. It's the same distance back and forth. So let's set up equation 1. Distance equals rate times time. We know her distance is 5 miles, and that should equal her rate times her time. We know her time's in 30 minutes. We want to make that consistent over the course of the problem. So we use hours here. I'm going to convert 30 minutes to half an hour. So the time is half an hour, and we don't know her rate. We're going to have to solve for that. Okay? On the return leg of the trip, we know she rides at a rate of 5 miles per hour. We don't know the time. That's an unknown, t. And we do know the distance. The distance must be the same back as it was going out, so that's going to be 5 miles. Now I have two equations, two variables, and I can go about solving for her speed over the entire trip. So a lot of students will look at this and they'll solve the first equation for r. R equals 5 divided by 1/2, which is 2 times 5. R equals 10 miles per hour. So her speed on the first leg is 10 miles per hour. They notice that her speed given on the return leg is 5 miles per hour. So in a lot of cases, students will simply say 5 plus 10 divided by 2, 7.5. That's her average speed over the entire trip. That would be wrong. 7.5 miles per hour average is incorrect. You cannot use mathematical averages for rates, something students often miss on distance, rate, time problems. Why? Because you'd have to be going the same amount of time at those rates to do a mathematical average. In this case, more time is spent at the lower speed, 5 miles per hour, than at the higher speed. So the resulting rate will be weighted by that. So we should expect it to be a little less than 7.5 in this case. Let's run the numbers and find out. We do know that we can create a total equation for distance equals rate times time. And the total distance we know is 5 plus 5. It's 10 miles back and forth. And we have some average rate. We don't know that. Let's keep that as the unknown variable. And now we do know the time. We could solve for t in that second equation. The time equals 5 miles divided by 5 miles per hour, which is simply 1 hour. So t equals 1. We can add our times. We could not add our rates, but we can add our times. That's 1/2 plus the 1 equals 3/2 or 1.5 hours. Now I can solve for r average in my total equation. The total rate or average over the entire course, over the entire trip, is 10 divided by 3/2 or 6 2/3 miles per hour. It was, in fact, a bit less than the 7.5 miles per hour. So that makes common sense. We're weighted toward the slower speed where Sally spent more time on that leg of the journey. So it pays to get to know a lot of these distance equals rate times time variations and a lot of these systems of equation word problems variations. I would spend some time practicing, but these are some of the basics and the issues you might want to look out for.